Hey guys, welcome again. So, in this lecture, we would be quickly talking and getting more in depth, and we will be talking about pod life cycle. So, the life cycle of typical pod goes something like this. You define it in a YAML or JSON manifest file, then you throw the manifest at the API server, and the pod IT defines get scheduled to a healthy node. Once it is scheduled to a node, it goes to a pending state, while the node downloads images and fires up any containers. The pod remains in this pending state until all of its resources are up and ready. Once everything is up and ready, the pod enters the running state. Once it is completed its task in life, it gets terminated and enters the succeeded state. If a pod fails, it is not rescheduled. For this reason, we rarely deploy them directly. It is far more common to deploy them via higher level constructs, such as replica sets, daemon sets, and deployments, which reschedule them when they fail. When a pod can't start, it can remain in the pending state or go to the failed state, which you can see in the figure. It is also important to think of pods as mortal. When they die, they die. There is no bringing them back from the dead. This follows the whole pets versus cattle analogy. Pods should be treated like cattle. When they die, they are replaced by another. There is no tears and no funeral. The old one is gone and a shiny new one with the same config but a different ID and IP magically appears and takes its place. This is one of the main reasons you should code your application so that they don't store state in the pod. And also why they shouldn't rely on individual pod IPs, etc. Now we would be quickly summarizing whatever we have studied. And in few steps. Number one, pods are the atomic unit of scheduling on Kubernetes. You can have Number two, you can have more than one container in a pod. Single container pods are the simplest, but multi-container pods are ideal for containers that need to be tightly coupled. Maybe they need to share memory or volumes. They are also great for logging and service meshes. Point number three, pods get scheduled on nodes. You can't schedule a single pod to span multiple nodes. Point number four, they get defined declaratively in a manifest file, that is a POST, to the API server and assigned to the nodes by the scheduler. Now quickly come on to hands-on with the pods. So let's see how pods work, how are they in action. So for the example, in the rest of this chapter, we will use a 3-node cluster. It doesn't matter where this cluster is or how it was deployed. All that matter is that you have 3 Linux hosts configured into cluster with single master and 2 nodes. You will also need the kubect1 client installed and configured to talk to the cluster. Following the Kubernetes mantra of composable infrastructure, we define pods. We define pods in manifest files. Pause them to the API server and let the scheduler take care of instantiating them to the cluster. Now, before we close this lecture, I would just take a minute to compare Kubernetes pods with VM in vSphere, as you can see in the screen. And since it is explanatory rather, so I'm not taking much of your time to explain it further. And this is one of the figures, and here comes the other one. So you can see how we can compare, the components of Kubernetes versus vSphere. Okay guys, so let's take a pause here, and we will we will have more lectures as we go forward. Thank you very much.